Problem?
No, sir.
So we have done the last class, we have done superposition. Remember that
Yeah.
whatever we have done as a superposition, interference is the same almost, but there is a small difference. We will see that now. First thing first, superposition was when two waves are actually, you can say jumping on each other, or you can say two waves are actually one on another. One time we have seen that. Let me just show the diagram to you. Let's suppose if this is the wave, and if the wave is like this, then the resultant wave will be like this. We give it a name called destructive interference. Why in destructive interference? Because the crest of one wave fall on the trough of another wave. So actually, this type of wave, the resultant displacement or resultant amplitude of the wave will be zero. And what if the crest of one wave fall on the crest of one wave and trough of the one wave fall on the trough of one wave? This kind of interference give you a wave having larger amplitude, and that type of interference we give it a name as constructive interference. But previously we didn't give them a name as interference. We say this is called superposition. One wave will be superposed on another wave, and one time it gives you a constructive interference and one time it gives you a destructive interference. Then we have done the difference between standing wave and progressive wave. We have seen that. Now, in this case, we will especially focusing on what exactly is the interference. So technically, this is just very next part of superposition. Now, superposition, we didn't talk about the wave. We talk about two waves, but we didn't talk about the frequency of the wave such as. And there are few terms which we need to know before we actually go for the interference. One is called as coherence and the other one is called as path difference. These two things are very important. Then and only then we will be understand the basic concept of interference. So let's move on. Now check this out. These are two different waves, and let's see what the coherence means. First of all, path difference and the coherence. Interference occur when wave overlap and their resultant displacement is a sum of displacement of each wave. This result is based on the principle of superposition, and the resultant wave may be smaller or larger than either of the two individual waves. We have seen that in superposition, that if the wave is one crest of the wave is fall on the trough of another wave, we give it a name called constructive interference. If one wave crest will be fall on the trough of another wave, we call it destructive interference, right? Now, what is coherence? At point where the two waves are neither in phase or nor in antiphase, the resultant amplitude somewhere in between the two extremes. Waves are said to be coherent if they are the same frequency or constant phase difference. Now, what does this means actually? If you check this out, first of all, for coherence, this is important that frequency of the wave should be same. Now, how can this be possible that the first condition will be fulfilled? Mahanur.
Same number of waves.
It simple means that frequency should be originated from the same source. The source should be same, because otherwise it's very difficult to have at least frequency same. Number of cycles per unit time should be same for both of the wave. Otherwise, your waves will not be coherent. Two waves can never be coherent. Okay.
Sir,
Now,
if say same frequency, can we also say same wavelength?
no, no, wavelength. I'm not talking about the wavelength. Wavelength can be different because wavelength, when you're talking about, it's a distance between two waves. I'm talking about number of frequency. Like, for example, one wave is this, and the
Yeah.
other wave is this. Now, frequency is different. On the top one, the
Yeah.
number of number of waves per unit time is more, and the down one, the number of waves per unit time is different. So if this is not the case, they are not coherent, not in any
Yeah.
case. So first condition is the frequency should be same. Then and only then we can move forward. So first condition is the same frequency. So waves said to be coherent if they are same frequency. Second, constant phase difference. Now, what is this means by constant phase difference? This is interesting actually. Check this out. Let's suppose this is one wave and this one is another one. Now, if you check it out, we can actually measure it very easily. This started from zero, this is started from zero. At zero, technically, if I increase it, half of the wave is actually gone and half of the wave is started. And if it will be constant throughout, yani means this is what we call the difference of the lagging is called as phase difference. If I ask you how many waves the second one have already passed before the first wave come in,
Um,
half
half
of
it.
half of the wave is already passed. So you can say that this wave is lambda by 2 phase difference ahead of the top wave. Or you can say the above wave is lambda by 2 phase difference ahead of the below one. Any one of two is ahead, either the second one or either the first one. I take it as the second one because half of the wave I can see. Here the maximum point comes at 0. Here the minimum point come at 0 and half of the wave actually already passed. So I can say the phase difference between these two waves is lambda by 2. Do you understand?
Yeah.
Now if you see here, check it out. This is 0 and this is maximum, right? It means if I
Yeah.
proceeded, for example, here, then it will be like this.
Yeah.
So what is the phase difference between two? Lambda by 2.
Yeah.
That is what we called as, now this lambda by 2 should be same for all the wave which are going through. So constant phase difference. If the phase difference is not constant, they are not coherent. For coherence, you need to have two things. One, same frequency coming from the same source. And secondly, the phase difference is the same. Whatever the phase difference is, it should be same. If it's not same, then they are not considered to be coherent. All
So
right?
lambda is from crest to crest, right?
Yeah.
So if
If, for example, I say phase difference 0, it means that this is the wave. This is phase difference 0.
yeah.
If one, for example, if this is the case, if this is, for example, the case, what is the phase difference? Lambda. Because actually the wave already passed. So the full wave is already passed. Here the difference is approximately lambda, not lambda by 2.
Why is it not lambda by 2?
Lambda by 2 means half of the frequency. Lambda by 2 is this one, this and this. See here, here the frequency started from crust and then trough. But if you see
Yeah.
here, half of the crust is passed. It means half of the crust actually passed before 0. Am I right?
Yeah.
So half of the crust means how much?
Lambda by 2.
No, it's not lambda by 2. I'm sorry. It's lambda by 4.
Yeah, by 4.
So it's
Because
lambda by 4. So it's not lambda by 2, lambda by 4. Why lambda by 4?
Yeah.
Because this full one is half, this full one is half, and this is half of the half. So the phase difference will be lambda by 4 in this. Now you understand?
Yes. Yes. Yeah.
For the same, like for the making you understand, I said lambda by 2. Actually, it is lambda by 4. fourth part
Yeah.
of the half wave. But if you see the one which is drawn at the bottom, you will find a very interesting fact. First of all, this one has a different frequency, this one has a different frequency. Am I right?
Yeah.
This is longer, this is shorter. So, first thing is the frequency is not the same. Second important thing, if you see the phase difference, they are not the same. Here it is something like this. So, change in the phase with above wave. Like if you see these two, can you tell me how much is a phase difference between these two? The blue ones, sorry, the green
Is
ones.
it the green ones? It's half lambda.
Yes, it's half lambda, absolutely, because half of the phase is passing through. So lambda by
Yeah.
2 is a phase difference. Now you understand the fact.
Yeah.
But if you see the second wave, which is a sort of, I think this is pinkish. No, not pinkish. What is this purple one?
Well, yeah.
Here, here the difference is different, and then here the difference is different. So phase having a different one. Phase is changed. The half of the cycle, the phase is different. The next half of the cycle, the phase is different. Then again, the phase is different. They look like coming from two different sources. It's not just a phase which is constant. Even the frequencies look like different. So they are not coherent. So Mahnur, if two waves, or you can say if two particular lights or whatever it is, are same, what is the condition for coherence?
And same frequency and constant phase difference.
Same frequency in general means coming from the same source.
Yeah.
And constant phase difference means if one wave is lagging behind or one wave is moving ahead of it, then whatever the lambda it is moving ahead, it should be constant all over. It will not be, for example, sometime it's ahead, sometime it's back. It will not be the case. So what is coherence means? A point where two waves are neither in phase or nor in anti-phase.
Sir, the green waves, neither in
Yes.
phase nor phase.
Again, can you repeat it? Your voice actually break up.
The green waves, are they both not in phase?
See, they are not in phase. You're right, absolutely. But you tell me, is it look like their frequency is different?
No, they look the same.
The frequency is same. That's what important point is. Only one difference is that they are out of the phase, as you just said it.
Yeah.
So they are actually out of the phase. They may be you can, but you just need to check it out how much out of the phase that thing is, because
Yeah.
one important, one important thing is actually fulfilled here. That is frequency. Because if the same frequency is coming, you may have a chance that that particular thing is basically coherent, except when the phase is continuously changing. Here, the phase is not changing. If the phase will be constant all over, if the first wave and second wave is continuously out of the phase for lambda by 2, or you can say the phase difference is continuously lagging lambda by 2, fine, no problem. It means they are coherent. But you can say
Yeah.
one thing, they are out of the phase. Because coherence
Yeah.
doesn't mean that they are in phase. Remember that. Coherence means that the resultant amplitude is somewhere in between the two extremes, either zero, either maximum. It can be zero, it can be maximum. But important thing is whatever the phase difference will be, it will be the same for all the journey of the wave. Understood?
Yeah.
Good. Now let's move further. Now, coherent versus a non-coherent wave. The abrupt change in phase create an inconsistent phase difference. Coherence is vital in order to produce an observable, hearable interference pattern. Now, this is important. Laser light is an example of a coherent light source, whereas filament lamps produce incoherent light waves. When coherent sound waves are in phase, the sound is louder because of the constructive interference. Now, what does all this thing is means? Important thing is, again, coherence. Again, I'm just explaining it again. What is the first condition for that? The
Same
frequency should be
frequency.
same. So it means that if you have a laser light, red laser light, for example, because it has one frequency, that is red, so whatever red frequency laser light will be considered to be in phase, or especially if you will have the same source from where you are taking two frequencies, it will be in phase. Now, in phase doesn't mean that crust will fall on crust or trough will fall on crust. It can be any. Like what I mean is, if the other wave is like this, where crust is falling on crust, or the same frequency where trough is falling on crust, no issues. As far as frequency is same, if there is a phase difference, no issues. There may be a phase difference. Now here, if you see that the path difference is lambda, check. This is crust trough, crust trough. Now here, constructive interference. Now what does it mean is, check it out. This is lambda, I mean frequency. Now check this out. What do you think? How much difference it is?
There is no difference.
There is. The reason is, if you see the wave behind, actually, this is the second wave which is coming at the first wave of the top one.
Okay.
One of the wave, full complete wave is already passed. If you ask me that how much difference it is lambda, technically speaking. What I wanted to say, now check this out. You will understand better. I will do it for the constructive interference. Check it out. This is your wave, right? Constructive, you tell me what is this interference?
Um,
This is,
for the
first of
first
all,
one,
yeah. What is, first of all, what is the, what do you call it? The path difference. Path difference is zero
yeah,
because crust will fall on crust and trough will fall on trough. So path difference is zero. Now check this out. Now, what is the path difference?
lambda.
Lambda. If I increase it further, now how much is the path
2
difference?
lambda.
2
2
lambda,
lambda.
3 lambda, 4 lambda. It means that n lambda is a generalized formula for the constructive interference. It means that if two waves are n lambda away, or there is a path difference of n lambda, then you can say that it's a constructive interference. Now you can take any n value, and that will be your path difference. So if path difference is n lambda formula, it will be a constructive interference. Otherwise, it will not be a constructive interference. It will be a destructive interference. So generalized formula for the constructive interference is n lambda. It's same like an nth term in mathematics.
Yeah.
Now let's take the example of destructive interference. Now you tell me what is the phase difference in this case?
It's half lambda.
Half lambda. So path difference is lambda by 2. If I increase one complete wave behind, how much it will be?
Lambda.
One complete wave,
Uh,
3 by 2 lambda.
how?
See, If I increase half wave, then it doesn't make any difference because this half wave is along with the one complete wave. Actually, what happened here? One complete wave already passed, and half of the wave is there now. Instead of adding half, why not you add the full wave? What my point is, see what I wanted to say. I will rub it when you understand better. This is the case of the lambda when lambda is lambda by 2, right?
Yeah.
Let's take an example that before this half of the wave already passed, one wave is already gone, one complete wave.
Yeah.
Now
That's lambda.
that's lambda. So lambda plus half lambda will be how much?
Oh, okay, okay, I get it now.
So it will be how much path difference?
3/2.
3 over 2 lambda. If one further lambda will be added into that, what will be the path difference? 1 plus
2.
5 by 2 lambda.
Yeah.
So if you generalize the term, what it will be is, yes, it will be 1,
Root.
3, 5, 7. So if you find out the a plus n minus 1 into d, then it will be 1 plus n minus 1 into 2. So it will be 1 plus 2n minus 2. So basically equal to 1, no, sorry, 2n minus 1. So the formula become 2n minus 1 upon 2 lambda. You place 1 into that, you will get 1 by 2. You place 2 into that, you will get 3 by 2 lambda. You put 3 into that, you will get 5 by 2 lambda. So this is the formula you have it. Or in general, you can do another thing. If you start from 0, it will be n plus 1 by 2 lambda. If you put 0, 1 by 2, if you put 1, no, not 1, it will be 2n minus 1. This is for the destructive or destruction interference. So part difference is the distance traveled by two waves from their source to the point where they meet. That is
Yeah.
what we called as path difference. So for constructive interference, the formula is n lambda. For destructive interference, it will be 2n minus 1 by 2 lambda. Let's see further what exactly it is. Do you understand, Manu?
Yeah. Yes, sir.
Good. Now check this out. Now they give you some example so that you can understand that. Let me rub. That is the one which is I just told you in a minute. This is basically S1, P1, the part difference. They just give you a different example than they showed it to you. It's not that important. Important is something else, which actually I will tell you. This is peaks and point sources. No, not this one. Now check this out, what the point is. The diagram shows an interference of a coherent wave from 2-point source. You tell me A, the X one. Which point is right in this? Check it out. See B, if you see that, they just showed it, they just showed it because crust fall on almost crust and trough falls on almost trough. So it will be constructive interference first. Second one will be
Yeah.
constructive and the third one will be constructive. All right?
The Z.
Yeah, it's B, right? Now, important point. At X, both peaks of the waves are overlapping. So part difference is equal to 5.5 minus almost 4.5 is equal to lambda. If you check it out, they give you lambda, right? That's
Yeah.
what if you remember, we have found out n lambda formula.
Yeah.
For Y1, if you check it out, it's 0. It means they are exactly in phase.
Yeah.
And the third one, it's destructive.
Yeah. So it's.
So basically, this one will be lambda by 2. Is it proven? Check it out.
So
0.
why is it 5.5 minus 4.5?
No, they just took some values randomly. But what they
Okay.
wanted to show you is if this is a whole number, then it will be a constructive interference. If it will be a sort of a fraction number, it will be a destructive interference. I'm talking about the path difference. Okay.
Yeah.
So here in these two cases, this is a constructive interference, while in the third case, I mean, it will be a destructive interference. So if you see Z here, it is a destructive interference as this case, crust fall on trough.
Yeah.
So remember, interference of two wave can either be in phase, causing constructive interference. The peaks and troughs line up on both the waves. The resultant wave has double the amplitude. In anti-phase, causing destructive interference, peak on one wave line up with the trough of the other. The resultant wave has no amplitude. Think of constructive interference as a building the wave and destructive interference as destroying the wave. Okay, understood?
Yeah.
Now, demonstration of the interference. Now, this is interesting. Check it out. This is basically Young modulus experiment. Now, when you demonstrate a Young modulus interference, what is the first thing you make sure? That it should be a monochromatic light.
Yeah.
Monochromatic light means it should be one light, not two. It should be a light with single light and coming from single source. Why from single source?
Coherent source.
Because they should be coherent. Because if they are not coherent, you will never get constructive or destructive interference at the screen. Right? And second thing is
Yeah.
now the phase difference. Now, interference and diffraction of laser can be demonstrated with slits or diffraction grading. For light rays such as laser light through two slits, an interference pattern form on the screen. Now, what does it mean also? You can see that this is Young double slit experiment. Now, what exactly it is? This is sort of a slit, a small space, and here as well, small, you can say, path through which the light will be passed. Now, my point is light has to go there and light has to go there. When light goes here, this is a screen right there. When light strike here, it will brighten this. Now, how do we find out this is a constructive interference? If the screen become bright, it will be a constructive interference. If the screen become dark, it will be a destructive interference.
Yeah.
Okay. Now,
Yeah.
what Young actually found out through this, first thing is diffraction. Diffraction means bending of light.
Yeah.
Bending of light from the edges. From the edges. So if light bends from the edges, we called it's a diffraction. Now, what happened? This is slit. It is a slit now. What happened? Light actually reaches to this point and it will go straight there. Then the second slit, you made it light go here. And after that, light also go there. And these two light, this one and that light make a constructive or destructive interference this place.
Constructive.
That's just for the case they showed you a constructive interference. Okay, so it can be a
Yeah.
constructive interference, it can be a destructive interference. But important thing is it will be what my point is. It can be a destructive interference. It can be a destructive interference. Okay. So important part thing is that light which comes at this place. I'm talking about this light. It has to cover some paths difference to actually combine with this light, or you can say interfere with this light ray. Am I right? Hello? Hello? Can you hear me, Manur? Hello? 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 Manur, can you hear me? Now, my point is the light which actually reaches to this point, it has to cover some distance to reach to this point, like
Yes.
this. So they will interfere. Now, this is the first point where they either do constructive interference or destructive interference. When it does constructive interference, it will be brighten up, and we call this as a bright fringe if it is a constructive interference. What we have seen is right after the below side, I mean, at below of this, there will be a dark, and then again there will be a bright sort of a sign, and then again there is a dark, then again there is a bright, then again there is a dark, then again will be a bright. So scientists believe, the young believe that wherever you find a bright sort of thing, it means light interference is constructive, and wherever you will find a dark fringe, you will find out that this interference is destructive interference. So on the screen, you will see a bright signs along with the dark signs. Each bright sign is called as fringe. So you have results as bright fringe or dark fringe. The question is, why do you get the dark fringes? Why do you get the bright fringes? So answer from the answer from the modulus was, he said the light has to be interfered. I mean, light do interference on the screen. Wherever you find the bright spots, light strike there constructively. He give it a name called fringes. So he has bright fringe, dark fringe, bright fringe, dark fringe on the screen. So what did he do? I'll just again repeat it. First of all, he took a monochromatic light source, or you can say a laser light, monochromatic, one light. He put it there before a double slit. Slit means very small space at the top, very small space at the bottom. So light will go from there straight down, and you will get a bright color over there. But this light, which goes to the second slit, where this light goes, we believe that this light will actually interfere with the light which goes from the first slit. So what did we see? That you find different color of fringes, one with the bright light, one with the dark light. So what scientists believe, that the bright color or bright spots are constructive interference of the light, while the dark spots or dark space are given name as a destructive interference. On a single line, you can see constructive interference, destructive interference, constructive interference, constructive interference. How do you see them? You will see them in a sort of a bright area or a dark area. Bright area or dark area, we give it a name called fringe. So now you will have bright fringes, dark fringes. The first fringe which actually obtain here at the first space is called as first order bright fringe. The first dark which is achieved over here for the first destructive interference is called as first order dark fringe. Same like you will have constructive or destructive interference once again, that will be the second order bright fringe and second order bright fringe. Manur, any problem in this?
No, sir.
Okay. Now you got all the fringes, bright fringe, dark fringe. You got the first order, bright fringe, the second order bright and dark fringes. Every single result you just found out here. Now, on the basis of this result, what did you do? It's written here. You check it out. Constructive interference is shown as a bright fringe on the screen. The highest intensity is in the middle. The destructive interference is shown as a dark fringe on the screen. These have zero intensity, means dark. Now, very interesting thing. They say the highest intensity is in the middle. Can you tell me the reason why here at this point?
In the middle.
In the middle. That's what they
It's
said. It depends
most of
on
the
the phase difference actually. The phase difference, as the phase difference is, but by the way, it's not the phase difference. What simple thing is, because it's in the middle, so what they believe is the highest intensity will be over there. Intensity means it will be, it's just a reason that it will be in the middle somewhere. But important thing is the brightness will be, wait, the brightest will be somewhere in the middle, which is absolutely the highest intensity. That's what we noticed. Okay, that is the, you can say, the result of the experiment we have just found out. Okay, now important thing, safety issue with the laser. That's what they are saying. Laser produce a very high energy beam of light. This intense beam can cause permanent eye damage or even blindness. In schools, only two lasers are allowed. There are lasers with power output of less than 1 milliwatts. However, more powerful lasers can reach outputs more than 500 milliwatts. Remember that as you increase the milliwatts, it will be more and more severe and dangerous for the eye injury. Okay. So they just give you a precaution, safety issues with the laser here as well. Precaution is, it is important to use laser safety and follow the guidelines. Never look directly at a laser or its reflection. Don't shine the laser towards a person. Don't allow a laser beam to reflect from the shining surface into somebody's else eye. Wear laser safety goggles. Place a laser on a warning light outside the room. Stand behind the laser. All right.
yeah.
This is also protecting eyes and the skin. For now, sound EM wave interference. Sound waves are longitudinal waves, so they made up of compression and rarefaction. Okay. Now a big thing, but let's see the young modulus once again, because they didn't give this a name as young modulus. Let's see the young modulus here once again. Where is it? Electric circuit, EMF resistance. Do you understand the young modulus thing? What exactly? Now, what is interference? Interference is a special case of superposition where the wave that combine are coherent. The wave overlap and form a repeating interference patterns of maxima and minimum area. If the wave weren't coherent, the interference pattern would change rapidly and continuously. Coherent wave is wave which are the same frequency, wavelength, polarization, and amplitude, and in a constant phase relation. A laser is coherent source, but a light bulb is not. Remember that light bulb have a different, frequency. That's the reason the light coming out from the light is not coherent. Now they already told you the constructive interference and destructive interference. I told you before. Now, if you see the young double slit picture here, this is the same thing if you see. Now, if you see at this place, which that's the reason I actually brought you here, you find this kind of colors: white, black, white, black, white, black, white, black. In 1803, Thomas Young settled a debate starting over 100 years earlier between Newton and Huygens by demonstrating the interference of light. Newton thought that light was made up of tiny particles called corpuscles, and Huygens said that light was a wave. Young interference of the light proves light is a wave. Here is Young double slit setup. The two slits act as a coherent. light source. Now, what exactly is happening? Interference occur where the light from two slits overlaps. Constructive interference produces bright area, where destructive interference produces a dark area. These areas are called interference fringes. Yes, Manu. Is it the same thing we have just studied few minutes ago?
Yes, sir.
No
Yeah.
difference at all, right? There is a
Yeah.
central bright fringe directly behind the middle between the slit, with the more fringes evenly spaced and parallel to the slit. As we move away from the center of the screen, we see the intensity of the bright fringe decreases. Now that's what he actually found out. He just found out this thing. They say that as we move away from the center, the color of the bright fringe, fringe reduces, or you can say will have a less color. That's what he found out. So intensity will be reduced. Intensity means displacement or amplitude. The highest amplitude is the fringe which is in the middle. Check it out. These are the bright fringes, but that bright fringe has the highest amplitude. So intensity of that bright fringe is highest. Okay, understood?
Mm. Yeah.
Now, furthermore, that's why I actually brought you here. There is a formula for this derivation. Now, what actually we need to find out? Fringe spacing. What is meant by fringe spacing? Each fringe is spacing. And the second is distance to the screen and wavelength are measured in meters. Now, what exactly it means? We can calculate the separation of the fringe if we consider the diagram to the right, which shows the first bright fringe below the center of the below the central fringe. The path difference between two waves is equal to one whole number. For constructive interference, if distance of the screen is d, is massive f compared to the separation of the source. The angle theta in the large triangle can be assumed the same as the angle in the smaller triangle. Now, this is actually very interesting thing. What actually we are trying to find out, that's what the point is. We are trying to find out the fringe spacing. Okay. I think we will stop it here. We will continue from this fringe spacing and everything tomorrow. And we will continue with this. And there are a few more things. But for the first thing, I want you to go through the young double slit experiment and everything. And we will be continuing this. Okay.
Okay.
Because this is a bit tricky thing. So what did we study? We study that for interference, we need two conditions. One, the light should be coherent. And for coherence, there should be two conditions. The light coming from the same source will have a same frequency. And secondly, phase difference should be constant, will not be changed all the time.
Yeah.
Once we have this case, then we will have a young double slit experiment which shows that light is a wave. How did it shows?
Yeah.
There are two slits or two places from where the light is going to the screen and hit each other. There are interference. So what did we see? That we will receive different colors of the fringes: bright fringe, dark fringe, then white fringe. So we actually achieve different orders of the bright and the dark fringes. Once we found out, now we are actually finding out the fringe spacing, source separation, distance to the screen, and the wavelength are measured in meters. Like, I can just show you the thing here. This is W is equal to lambda T upon S. What is this T? D will be the separation between the source. Lambda will be the wavelength. And what is S in that case? S will be what?
S
S will
is
be the separation between the two
separation.
slits. So actually, technically speaking, you know all the things, right? Lambda, definitely you should know the wave you
Yeah.
are using. The D is a distance. You should know while you are doing the experiment that what is the distance between the screen and the source. And S is the distance between two slits. So by actually finding these value, you can easily find out the W value. What is W value? W value is called fringe spacing, separation of the fringes. Now, what exactly it is, we will see it in the next class. Okay. See you till. I
Yeah.
will upload this lecture as well. So if you want to see that, you can consult to our coordinator. He will show it. Okay.
Okay. Yeah.
Okay. Then take care. Bye.